Topic 2 in this unit is on temperature. In this chapter, we're going to look at the temperature scales as well as converting between the three different temperature scales. At the end of this lesson, you need to take the quiz on Schoology as well as watch the video on absolute zero and why we use the Kelvin temperature scale. The three main temperature scales are Celsius, Fahrenheit, and Kelvin. The Celsius temperature scales is used by most of the world and the scientific community, and it's also the temperature scales that the thermometers that you use in class record in. Some of the main temperature in Celsius would be 0 degrees Celsius is the normal freezing point of water at 1 atmosphere, and 100 degrees Celsius is the normal boiling point of water at 1 atmosphere. The Fahrenheit temperature scale is probably the one you're most familiar with. It's the one used by most of the people in the United States of America. It's the ones that you see on the bank thermometers as well as on TV and so forth. The common temperatures for Fahrenheit would be 32 degrees Fahrenheit is the normal freezing point of water, and 212 is the normal boiling point of water. Both of those are at 1 atmosphere. Later on, you'll see that when you change the pressure, you end up changing the freezing and boiling point of different situations. The Kelvin temperature scale might be new to you. It's used in the scientific community to plug into calculations, and these calculations and formulas you use later on with topic 3. And the reason why we use the Kelvin temperature scale is because we don't want to use negative numbers or 0 in any of these formulas because it'll just throw everything off. So the normal freezing point of water is 273 Kelvin, and the normal boiling point of water is 373. And notice there is no degree symbol before the K. And then something else that we're going to look into later at the end of this lesson is what is called absolute zero. It's 0K. Scientists have determined that just use 0K as the lowest possible temperature and then go up from there. To convert between Celsius and Fahrenheit, use the formula degrees Celsius times 1.8. Get that answer and add 32 to it, and that'll give you your temperature in degrees Fahrenheit. Now for these next couple, there'll be example problems, and you can try them out yourself and then go on to the next slide to see what the correct answer is. So if you plug 25 in, you get 25 times 1.8 plus 32, and that gives you your 77 degrees Fahrenheit. Another example problem, plug 77 in for C, multiply by 1.8, add 32, and you get your answer of 171 degrees Fahrenheit. Plug negative 10 degrees Celsius into the formula, and you add 32 to it, and you get 14 degrees Fahrenheit. Negative 77 degrees Celsius, plug that into the formula, and you get negative 107 degrees Fahrenheit. Remember, adding and subtracting, you go with the least number of decimal places, so that's why it's rounded to a whole number like it is. Now to go from Fahrenheit to Celsius, you take your given Fahrenheit temperature, subtract 32 from it, take that answer, divide it by 1.8, and that'll give you your Celsius. So try it with 98 degrees Fahrenheit. 98 divided by, or minus 32, divided by 1.8 gives you 37 degrees Celsius. 75 degrees Fahrenheit plugged into the formula. You get 43 divided by 1.8, and that gives you 24 degrees Celsius. 3 degrees Fahrenheit, divide that by 1.8, you get a negative 16 degrees Celsius. and negative 15 degrees Fahrenheit, plug that into the formula, negative 26 degrees Celsius. Celsius to Kelvin. This you'll use more often, possibly if you take AP Chemistry or if you do a lab in class. The thermometers we use register in Celsius, so you take your Celsius, you have to add 273 to it, and that gives you your Kelvin, and then you can plug that temperature into later formulas that you'll learn in topic 3. So 0 degrees Celsius, add 273, you get 273 Kelvin. 100 degrees Celsius, add 273, 373 Kelvin. 77 Kelvin, add, what you end up doing for this one is, since you put the 77 on the right side of the equal sign, you have to subtract 273 from both sides. And you end up with negative 196 degrees Celsius. That happens to be the temperature of liquid nitrogen, so you can see how cold that really is. 1025 Kelvin, you're going to subtract 273 from it and get 752 Celsius. Finally, we have something called absolute zero. By definition, this is the temperature at which all molecular motion stops. We haven't been able to accomplish this just yet, but scientists have been getting closer and closer to it. But ideally, if you can get down to 0 Kelvin, then all motion within molecules ends up stopping. So what you can do now is go back to Schoology, and you can take the temperature conversion quiz and or watch the video on absolute zero and then take the quiz after that. It's up to you.